Good morning. So myself, Dr. Maheswara Rao, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics, and the topic is compressibility. So that we are going to deal today. So before going to that, so we are having the course outcomes. So that means after completion of the course, so what the students will be able to do. So that is in that course 1 belongs to this properties of fluids. Okay. So properties of fluids means how it behaves and what is the density and what is its viscosity, like all the properties we will understand. And also surface tension at different conditions, that will come under the course outcome 1. So then course outcome 2 belongs to the Newton's law of viscosity. So fluids are divided into basically 2 types based on the Newton's law of viscosity: Newtonian fluids, non-Newtonian fluids. Okay, and also the problems related to the viscosity they learn, that is will come under the course outcome 2. Then course outcome 3 is the capillary rise or fall. That means if you insert a small diameter pipe in a fluid, the fluid will rise in the small diameter pipe, or sometimes some fluids will fall. That means the level will be fall inside the small tube. So which is the property of the fluid? That property is called a capillary rise if it goes up, and it is called fall, capillary fall, if it goes down beyond the top level of the fluid. That is the course outcome 3. So then course outcome 4 belongs to the surface tension. So how it is used, where it is used. Okay, this is surface tension, means in the name itself it is having any fluid will have some tension at the surface of this, the surface of particular fluid. So if it is a fluid, there will be tension at the top. So understanding of this concept will come under the course outcome 4. Then capillarity and compressibility. So capillarity means it is nothing but rising or falling, and compressibility means how the volume changes. So if you apply a load, then how much the particular fluid will compress. So which is called the compressibility. So that is come under the course outcome 5. So if you see course outcome 6, so that is the pipe flow. That means if you are allowing the fluid in a pipe, then how it reacts and what are the losses. So if it travels through the pipe, any fluid, it will lose some energy. So how much energy is lost and how much pressure is lost, all these things will come under this fluid friction. So because of the friction, the fluid will lose the energy, some of its energy. So that will come under this course outcome 6. Today we are going to deal this compressibility. You can see the figure here. It is a syringe. If you fill up this with air naturally, so it will stop here. Then if you compress it, it will be compressed a little distance. After that, it will not be compressed. So for a given load value. Okay. So that is called a compressibility. So different fluids will have different compressible values. That means there is nothing but a relative volume change. So how much this fluid occurs change in volume compared to the other fluid, how much that other fluid getting the change in the volume. So that is called a compressibility. Initially, why should we know this compressibility? So here 2 types of fluids are there: compressible fluids, incompressible fluids. So compressible fluids will have a nature of change in volume depending upon the apply of the load, and whereas incompressible fluids will not change in volume. So water will come under the incompressible fluids. That means water will take it as incompressible because the volume change is very, very negligible. Okay, that's why what is called as incompressible fluid. Whereas air, gas, that can be compressed relatively more. That's why the gas will come under the compressible fluid. So compressible fluid, incompressible fluid. And why it is required initially? So why should we learn this compressibility? What is the reason? Okay. So where it is applicable? So example, if we see an aeroplane. Okay. So if aeroplane travels at a certain speed, so let us assume it is 500 kilometers per hour. Okay. So if it is 500 kilometers per hour, and the same flight, if it travels 1200 kilometers per hour, so then what will happen? The air at the time of 500 kilometers per hour, the air will have some impact on this, because at that speed it will exert certain pressure on the air, so that air will be compressed at that 500 kilometers per hour. But whereas if it travels at 1200 kilometers per hour, so what will happen? Because of the speed is increased, the density of air at these wings also increases. Okay, so that's more density will be there, and less volume change will be there of the gas or air. So comparing to the flight with the speed of 500 kilometers per hour. So that's why the wings should be designed such that, okay, at the highest speed it should withstand. So for that purpose, okay, so for that design purpose, we have to know this compressibility. Similarly, you can take turbine also. Turbines, pumps, okay. So turbines also will have that fan-like wings here, so that if any water falls on that, it rotates. Okay, depending upon the speed of that water falls, it will have withstand. Okay, so that means the wings should be designed such that it should take the load, it should withstand at the highest pressure of the falling water. So that is the reason we have to learn, we have to understand this compressibility. Then you can see this. Compressibility is a measure of a relative volume change of a fluid or a solid. So not only fluids, it is also a solid as a response to a pressure change. So if we change in pressure, how much volume is reduced? So as you can see here, it is a liquid and if it is a gas. So you can compare this. So this is a datum line. So this much is compressed here. So because liquid is mostly compared to gas, it is less compressible. That's why a little portion is volume change. But whereas this extra portion also volume change occurred in addition to this one. Okay. So total more volume change has occurred for the gas for the same amount of load here. So this is a load or pressure applied mass. Then here you can see this incompressible fluids and compressible fluids. What does it mean here? Intermolecular distance. Why the gases are having more change in volume, and why not the liquids are not having that much change in volume? So example, you take water and gas. So water is, can call it as incompressible fluids because it will not get any change in volume as you apply the load on it. Okay. So because you can see this intermolecular distance. So that means the molecule distance between the molecules in a liquid and the water is more. That means is less, so that it cannot be compressed here. Whereas the intermolecular distance is more in case of gases. So if it is a molecule, here is example sake, if it is a molecule and a molecule, so the distance from all these is compared to more compared to the water. Okay. So that means if you take water, it will have molecules very nearer to that. That's why it is, water is called here incompressible fluids, because intermolecular distance is very less That's why it will not get any change in volume. So that's why incompressible. Whereas a gas is called as a compressible fluid because the intermolecular distance you can see in this figure. Okay, so more the distance between the molecules. Hence, if you apply a load or pressure, so it will compress a lot. So there will be more volume change in case of the gases. Okay, that's why the gases are called compressible fluids. So whereas the water, the intermolecular distance is very less, so it cannot be get more volume change. That's why the water will come under the incompressible fluids here. So here water is there and gas is there. You can see here another term is density here. Okay, so what will happen? Intermolecular distance is more, that is a gas, that is come under the compressible fluids. If intermolecular distance is less, that is incompressible, that is example is water. Similarly, density. If density is constant, so if density is constant, that means whatever our load applies, whatever the pressure applied, the density will not change. That means the density is constant. So the example for that is a water. So that is also called a incompressible fluids. If the density is constant, not changing, that is a incompressible fluids. If density is varying, see here, the density is varying. That means as you apply the load or pressure, the density volume is change in volume is increasing. Change in volume is increasing. That is called a compressible fluids, which is a gas. Now similar to that, if you apply a load or pressure, the density also varying. So as you apply the more and more load or pressure, the density will getting more and more. So that's why it is called a compressible fluids, gas. So if there is a change in volume, more change in volume, or if there is a more change in density, okay, so both are called as the compressible fluids. If any fluids are having that property, it means if there is more volume change or if there is a density change. So not only volume change, density change, we will come under the compressible fluids. If there is no change in density, if there is no change in volume, those fluids are called incompressible fluids. Example for incompressible fluid is water. Example of compressible fluids, that is a gas. So then key concept here. So what is this? Inverse relationships. What is the meaning of inverse relationships? So inverse means something is rising, another one will be fall, which is called the inverse relationships. There will be two types of relationships: directly proportional, indirectly proportional. Okay, so that means if something is rising, another thing is also rising. That means X is rising, Y is also rising. Okay, that is called directly proportional. So if X is falling, reducing, Y also falls. So that is also called directly proportional. And indirect proportional or inverse relationship is something is rising. If X is rising, Y is falling. Or X is falling, Y is rising. So which is called here inverse. Inverse relationship or indirect proportional. So directly proportional, indirectly proportional. Okay. So that means if something is rising, another one also will rise. If something is falling, another one will also fall. Okay. So example for this is if mother is crying, baby will also cry. So if mother is laughing, and baby also will laugh. So that is a directly proportional. Whereas if you take in the movies any hero and a villain, so if a villain is getting sad, hero will get happy, or villain is getting happy, hero will get unhappy. So one is rising, one is falling. So which is called here inverse relationships. So here, what are the things with the compressibility? It is nothing but the bulk modulus. So bulk modulus of that particular fluid. So if bulk modulus is high, compressibility is less. So if compressibility is high, bulk modulus will be low. So this compressibility is indirectly proportional or inversely proportional to bulk modulus. So they are inverse relationship they are having. So here, why should we this? It's importance in fluids. Why should we learn this compressibility here? Compressibility affects how fluids respond to pressure changes. So because of the understanding this concept, how this compressibility affects the fluid response, how the fluids respond to the pressure. Okay, and impacting sound speed. So sound speed means velocity of sound in particular media. So that also impacts. That means how this sound is traveling. That depends upon this compressibility, whether it is having more incompressible fluid or incompressible fluid, like that. And also pressure wave propagation. Okay, so these are the important in the fluids. So whether how the fluid is responding to the fluids or how this compressibility affects the fluids respond to the pressure changes, or how this sound speed is changing depending upon the compressibility of that particular fluid, or pressure wave propagation of that particular fluid. So you can see here some formula. So I already told you this is beta is 1 by K. Here beta is called the compressibility of that particular fluid, where K is the bulk modulus. You can see this. So bulk modulus. So if bulk modulus is less, that compressibility will be more. If compressibility is less, bulk modulus will be more. The formula will be is like this. So 1 upon V dV by dP. So this is the formula for the compressibility, or inversely proportional to bulk modulus, where K is equal to bulk modulus and V is equal to original volume and P is equal to pressure. dV is change in volume. Applications. So where this will be applicable. So the compressibility property, where it is applicable. You can see here aerospace engineering and hydraulic systems. Two applications are there. So in the aerospace engineering also it is useful, and also it is useful in hydraulic systems. Okay. So how this aerospace engineering affects, you can see now. So compressibility of air becomes significant at high speed. That means if the plane speed is high, if the plane speed is increasing, so 200 kilometers per hour, 300 kilometers, 500, 700,000 kilometers per hour. So as it is rising in the speed of the plane, then the compressibility of air also will be significant. So more compressibility will occur at the higher speed of the plane. So affecting the design of aircraft or spacecraft. So okay. So in the case of spacecraft or in the case of aircraft also, the design will depend on this compressibility of air. So because at higher velocities it will have significant effect. So that's why while designing this aircraft or spacecraft, so we have to know the concepts of this compressibility of the air, and also similar to that hydraulic systems. So here, which one is required? Low compressibility is desired. So whenever the fluid is having low compressibility, then that is useful in case of this design of the hydraulic systems. Okay. So it is desired for fluids used in hydraulic to ensure efficient transmission of the force. So why should it should be low compressible? So if it is a low compressible, that means mostly incompressible. Whatever the load you are giving, the load will be transmitted efficiently. Efficiency of the load transmission. So from one point to another point, if you apply it, so efficiency of the load transmission. Suppose 10 kg, this also will be 10 kgs or 9 kgs. So more efficiency will be there. In case of high compressibility means compressible fluids. So that whatever the load applied here will not be transferred here. So if it is 10 kg, maybe 1 kg, like that. So compared to that. So low compressibility fluids is desired to design this hydraulic systems. Engineering considerations here. So one is sound propagation. Another is design of compressors. What is this sound propagation? So compressibility affects the speed of sound. So the speed of sound will depend upon the compressibility of the fluids. So the speed of sound in air, speed of sound is different, and in water, speed of sound is different. So this Y means it is because of the compressibility. So if the compressibility will affect this speed of sound here. So incompressible fluids will have higher speeds, higher sound speeds. So which one will have more speed, higher speeds? You can see here, water is incompressible. That's why the sound can be traveled very fast here. Whereas in the air also water will travel, sound will travel, but at a lower speed compared to the sound speed in the water, because air is a compressible fluid and water is an incompressible fluid. So there will be maximum velocity of the sound, speed of the sound in case of incompressible fluids like water. And sound speed is less in the air compared to the water because it is a compressible fluid. So air is a compressible fluid. That's why air molecules will come closer to that, so that sound speed also will be less in the air compared to the water. And design of compressors. So here, so understand the compressibility of gases. Okay, here compressors is there, turbines is there. Okay, two things are there. So if you want to design the compressors, or if you want to design the turbines also, so that is called the design of compressors. So also depends upon the compressibility of gases. Okay, so both these will depend upon the compressibility of any fluids, maybe gases. So in case of aeroplane, okay, or in case of turbines, okay, so that compressibility will have more impact on the design of the compressors. So summary here, compressibility is the key property that influences how materials and fluids respond to the pressure changes. So it is critical in applications ranging from fluid mechanics to fluid science, where pressure variations are common. So if you review this, so here compressibility is a measure of a relative change in volume. Okay, so it is a relative change in volume. It is called a compressibility. You can observe this syringe, and the aeroplane is having more speed and less speed. So density of air at the wings will be more and less depending upon the speed of the aeroplane. And you can see observe this water is incompressible, or liquid is incompressible, so it will have very less change in volume. Whereas gas in the second figure is having more change in volume. And here, molecular distance. One is that molecular distance is more for the compressible fluids and less molecular distance for the incompressible fluids. So water will have less molecular distance and air will have more molecular distance. And also density. So density is constant, is not changing. That is incompressible fluids, water. And if density is varying, changing. So that is a compressible fluids. The example is the gas here. So inversely proportional, this bulk modulus is there and compressibility is there. So compressibility will have inversely proportional to the bulk modulus. So bulk modulus is rising, compressibility decreasing. If compressibility is rising, bulk modulus will be decreasing here. That is called inversely proportional or inverse relationship. These compressibility and bulk modulus is having. So one is high and is low. Another is high, one is low. So key concepts, how this fluids compressibility affects the sound. Okay, fluids respond to the pressure changes or impact of the sound speed, pressure wave propagation. All this depends upon the compressibility of the particular fluid. So the formula is there, beta, which is compressibility, is inversely proportional to bulk modulus. That is beta is equal to 1 by k. Here k is the bulk modulus, and formula is 1 by b, dou v by dou v. So that means change in volume, change in pressure, and v is the original volume. That is a compressibility formula. So compressibility beta is equal to 1 upon v to dv by dv. The practical applications are aerospace engineering. So at the higher speed of aerospace compressibility, it will have significant effects on the speed. So if the in this aeroplane speed is high, so it will have more compressible. That means air is compressible, more compressed at higher speeds here. So to design the aircraft or spacecraft, so we had to see the consideration of this compressibility of air. Similarly, hydraulic structures like hydraulic systems like this, how this compressibility is designed hydraulic to ensure efficient transmission of the force. So how the force is transmitted from one point to another point depending upon the compressibility. So if the low compressible fluids are there, the efficiency will be more. That means same load will be transferred mostly in case of low compressible fluids. Engineering consideration, that means speed of the sound speed. So incompressible fluids will have more sound speed compared to the compressible fluids. That means water will have a maximum speed of sound, whereas air will have less sound speed in its through that medium. Okay, and also design of compressors. So you see these turbines and compressors. Okay, so if you want to design the compressors or turbines, so we have to know this concept of compressibility. The summary is that so compressibility is a key property that influences how materials of fluids respond to pressure changes. Another one is it is a critical application ranging from fluid mechanics to material science. So not all say fluid mechanics and material science where pressure variations are common. So particularly if pressure variations are common, then it will be applicable. The references are K. Subramaniam. Name of the title of the book is The Theory and Applications of Fluid Mechanics, Tata McGraw-Hitch 2012. And whereas Modi PN and SM Seth, Hydraulics and Fluid Mechanics is the title. The Standard Book House 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.